Hello and welcome to my session. I'm Kostiantyn Vyshynskyi, and today we are going to talk about isolation and dedicated hosting in public cloud. Here is our agenda. I will try to cover some basic concepts in Azure, talk about isolation options, dedicated host, and app service environment will be covered massively in the second part of this session. This is me. I'm solution architect at Sequel with more than 15 years experience in software development. I had bunch of certificates related to Azure platform and also architecture discipline. Our first topic is main concept in the public clouds. Hopefully, main audience will be advanced Azure practitioners. Nevertheless, let's just bring attention on the main cloud concept. This concept includes three models: infrastructure as a service, platform as a service, and software as a service. We also have capabilities to bring our computation and hardware resources to cloud as private cloud. But usually it's an on-premise environment with a direct connection to the public cloud or isolated boundary. Returning to the concept, we have different responsibilities for provider and participants. And similar for all models, responsibilities for the hardware that is covered by provider. Just remind that the cloud provider, in our case Azure, provide their data center for a dozen customers. Unfortunately, it's also include the risk of sharing physical servers and other infrastructure resources to your sensitive application and VMs that may belong to an arbitrary or potentially malicious user. But don't be scared. Let's review isolation concept in Azure. The first option is tenant level isolation. In the cloud-enabled workplace, a tenant can be defined as a client or organization that owns and manages a specific instance of the cloud service. With the identity platform provided by Microsoft Azure, a tenant is simply dedicated instance of Azure Active Directory or Azure AD that your organization received and owned when it signed up for Microsoft Cloud Service. Each Azure AD directory is distinct and separate from other Azure AD directories. Just like a corporate office building in a secure asset specific to your only your organization, and Azure AD directory has also designed to be a secure asset for use by only your organization. The Azure AD architecture isolated customer data and identity information from Mindwick. This means that user and administrator of the one Azure AD directory cannot accidentally or maliciously access data in another directory. Another concept is compute isolation. Microsoft Azure Compute Platform is based on machine virtualization. This approach means that your code, wherever it's deployed in platform as a service worker role or an infrastructure as a service virtual machine, execute in a virtual machine hosted by Windows Server Hypervisor. On each Azure physical server, also known as a node, there is a type 1 hypervisor that runs directly over the hardware and divided to the nodes into a variable number of guest virtual machines. Each node has one specific host VM, also known as root VM, which runs the host OS, a customized and hardened version of the latest Windows Server, which is stripped down to reduce the attack surface and includes only those components necessary to manage the node. Isolation of the root VM from the guest VMs and the guest VMs from another is a key concept in Azure security architecture that forms the basis of Azure Compute Isolation. Physical servers hosting VMs are grouped into clusters. They are independently managed by a scale-out and redundant platform software component called as Fabric Controller. Each Fabric Controller manages the life cycle of VMs running in its cluster, including provisioning and monitoring the health of hardware under its control. For example, the Fabric Controller is responsible for recreating VM's instances on healthy servers when it's determined that the server has failed. It's also allocated infrastructure resources for tenant workload, and it manages identical communication from host to virtual machines. Dividing the compute infrastructure into clusters, isolated faults at the fabric controller level, and presents certain classes of errors from affecting servers beyond the cluster in which they occur. A fabric controller is the brain of Azure Compute Platform, and the host agent it is its proxy, integrating servers into the platform so the Fabric controller can deploy, monitor, and manage the virtual machines used by you or Azure Cloud Services. The hypervisor or hosting operation system pairing applies dedicated of Microsoft's experience in operating system security, including security focused investment in Microsoft Hyper-V to provide strong isolation of guest VMs. Next one is network isolation. Azure deployment has multiple layers of network isolation. The following diagram show various layers of network isolation. Azure provides to customers. These layers are both native for Azure platform itself and customer-defined features. Inbound from the internet, Azure DDoS provider DDoS provides isolation against large-scale attacks against Azure. The next level of isolation is customer-defined public IP address endpoint, which are used to determine which traffic can pass through the cloud service to the virtual network. And native Azure Virtual Network Isolation ensure compute isolation from all other networks, and that the traffic only follow through user configured passes and methods. These paths and methods are the next layer where network security groups or user-defined roles and network virtual appliance can be used to create isolation boundaries to protect the application development in the protected network. Virtual networks or VNets provide isolation of network traffic between tenants as part of their fundamental design. Your Azure subscription can contain multiple logically isolated private networks and include firewalls, load balancers, and network address translation. Each VNet is isolated from another VNet by default. Multiple deployments inside your subscription can be placed on the same VNet and then communicate with each other through the private AP addresses. And network addresses to VMs is limited by packet filtering of a network edge at the load balancers and at the host OS level. You can additionally configure your host firewalls to further limit connectivity, specifying for each listening port where the connections are accepted from the internet or only from the raw instance within the same cloud service or VNet. And the last one is storage isolation. As part of its fundamental design, Azure separates VM-based computation from the storage. This separation enables computation and storage to scale independently, making it easier to provide multi-tenancy and isolation. Therefore, Azure Storage runs on separate hardware with no network connectivity to Azure Compute, except logically. This means that when a virtual disk created, disk space is not allocated in its entire capacity. Instead, a table is created that maps addresses on virtual disk to areas of the physical disk, and to the table is initially empty. The first time the customer writes the data to the virtual disk, the space of the physical disk is allocated and pointer is to it is placed in the table. The next part of our session it's Azure Dedicated Host. Azure Dedicated Host is an Azure service that provides physical server able to host one or more Azure virtual machines for Windows or Linux, dedicated to one Azure customer. This is not a bare metal service. It provides a virtualization environment that architect to run Azure VMs, and it gives you control and visibility over the underlying physical server. As you provision the host, you gain visibility into the control over the placement of your Azure VMs, and you determine the host maintenance policies. And also, you can take a look for the list of main features addressed by the Azure dedicated host. Here is a simple diagram, a representation for host level isolation that helps address compliance requirements. Azure dedicated hosts provide hardware isolation at the physical server level. No other VMs will be placed on your hosts. So dedicated hosts are deployed in the same data centers and share the same network and underlying storage infrastructure as other non-isolated hosts. Also, we need to highlight that these dedicated host groups exist. So dedicated host group is a collection of Azure dedicated hosts deployed within an Azure region across different fault domains to avoid a single point of failure. This figure will help you understand how virtual machines and VM scale set that running on your dedicated hosts are related to especially dedicated host group and dedicated host. VM can be assigned to the host group or directly to the host, and virtual machine scale set should be deployed only to the host group. Both computation resources should be synchronized by availability zone parameter that is optional by default. High availability concept require from you deploying multiple VMs spread across multiple hosts at minimum of 2 dedicated hosts. With Azure dedicated host, you have several options to provide your infrastructure to shape your fault isolation boundaries. You can use availability zones for fault isolation. This means availability zones are like provide a unique physical location of your resources within the Azure region. Each zone is made up of one or more data centers equipped with independent power, cooling, and networking. A host group is created in single availability zone. Once created, all hosts will be placed within that zone. To achieve high availability across zones, you need to create multiple host groups, and especially one per zone, to spread your hosts accordingly. You can also use fault domains for fault isolation. This host can be created in specific domain, just like VM in scale set or availability zone. Hosts in different full domains will be placed on different physical racks in the data center. When you create the host group, you are required to specify the full domain count. When creating a host within the host group, you assign the full domains for each host, and the VM doesn't require a full domain assignment. Definitely, you can use both capabilities together and achieve even more fault isolation. In this case, you will specify the availability zones and full domain count in each host group. Assign a full domain to each of your host group. Will like assign the availability zones of each VM. And the interesting part related Azure dedicated host is pricing. And hopefully it's interesting topic for you, and you should consider the next aspects of this. It's especially pricing, additional billings, and cost optimization strategies that can be applicable to your environment. So Azure dedicated host pricing based on the VM family size, amount of virtual CPUs and RAM, and also geography. At the same time, we are free of charge for VM deployed to this host. So you are still eligible to host your VMs elsewhere for additional billings. As for other payments, we will need to pay separately for software licensing, storage, network usage. Fortunately, there is some areas of cost optimization tactics. You are eligible to use Azure Hybrid benefits, especially Ultimate Virtualization for SQL Server and Windows servers. This means you will pay only for license costs only for the physical course of your host, and will be able to run unlimited VMs under the same license without additional charges. Another options it's reservation for 1 or 3 years. Azure Reservations, it's a program on, in other words, agreement when you are committed to pay for your resources during the 1 or 3 years. The financial part of this agreement can be done via upfront payment, or you can break into monthly payment and pay each month some part of your costs for the resources. This agreement help you to save up to 32% of your cost. And we're just talking about the Azure dedicated host itself. You can create any infrastructure setup for your company or project, but please don't forget that we have some quotes and limitations on the CPUs. So we are limited on the amount of virtual CPUs per region, on the virtual machines size family. You can also increase this quota by creating a simple support ticket to Microsoft. Previous part described infrastructure as a service concept and dedicated options. Now let's review the available platform as a service capabilities of Azure platform. Before we start describing Azure Application Service Environment or ISE, we should stop for a few seconds on the Azure App Service itself. Azure App Service it's fully managed platform as a service hosting. You can run and host both Windows and Linux based web applications, mobile backends, API applications, Docker containers, Logic apps, and even Azure functions. Azure IC is a single tenant instance of Azure App Service that runs under the run in customer Azure virtual network. It solves many isolation scenarios for customers in a way you cannot cover with multi-tenant services. Especially, it's related to the horizontal scaling scalability issues. For example, your web application are hosted on the shared environment, where the most of the available resources and some memory and other stuff already occupied by other customer directly in the host. You will run into problem when you try to get the scale of your services, and you will get some errors that you cannot even increase the count of instance for your web application. So it's so simple. This can be solved by putting your Azure App Service in the dedicated environment with a guarantee of scaling up to 100 instances of your application inside the single app service plan. By the way, App Service Environment v3, the underlying technology is based on virtual machine scale sets instead of cloud services, which solve a lot of problems from the previous version. App service environment are appropriate for applications workload that require large scale isolation and secure network access, high memory utilization, more requests per second. You can make multiple app service environment in a single Azure region or across multiple Azure regions. This flexibility makes an app service environment ideal for horizontal scaling uh, for stateless applications with a high RPCs requirements. App service environment hosts application from only one customer and do so in one of their virtual network. Customers have fine grade control over inbound and outbound application network traffic. Applications can establish high-speed secure connections over VPN to on-premise corporate resources. Also, ICv3 has several minor changes in the system architecture that serve to remove all management traffic from the customer VNet. The end result is a single tenant system that has no internet hosted dependencies in the customer network. So customers can secure their workload on their hard consent without hurting an IC, and Microsoft can secure the infrastructure without hurting the customer's workload. The system enable both parties to apply all the security they want to without affecting each other. With app service environment v3, there is a different pricing models depending on the type of app service environment deployment you have. Here are the three models. So simple app service environment. Using this model, you will have straightforward billing depending on your amount of instances. But if your app service environment is empty, there is a charge if you had one instance of Windows, so smallest one. The one instance charged is not additive charge, but it's only applied if the app service environment is empty. Second model is zone redundant app service environment. There is a minimum charge of 9 instances. There is no added charge for availability zone support if you have more than 9 or more app service plans instances. But if you have less than 9 instances of any size across app service plan, in the zone redundant app service environment, the difference between 9 and running instances count is charged and as additional Windows smallest one instance. And last one model is dedicated host app service environment. With dedicated host deployment, you are charged for 2 dedicated hosts per pricing at app service environment v3 creation. Then a small percentage of isolated v2 rate per course charges at your scale. Yeah. So, and here is time to bring some light on difference between Azure App Service Environment v2, Azure App Service Environment v3, and regular Azure App Service on the premium v3 plan. Here is a table to summarize most of main limitations. Both Azure App Service Environment v2 and v3 have the same top limit of application instances during the horizontal scaling process and are set up to 100 instances. But Premium v3 App Service has only up to 30 instances based on the SKU size within the same scaling process. At the top of the table, you can find limitation of the app service plan instances, and there is the same for application instances on v2 and v3. On the region, but for the subscription, App Service v3 can have up to 200 of total App Service instances across all App Service plans combined. And Premium v3 App Service is limited to 100 App Services per resource group. Also, one of not public limitation related to ability of your application to serve high RPCs its amount of IP connections. IC v2 and v3 are covered by 16,000 connections, and Premium v3 based on the instance size handle only up to 8,000, and it's on the biggest one instance size. Storage size also varies based on the plans type. ACV2 and V3 can have up to 1 terabyte of storage, and Premium V3 only 250 gigabytes. But you can create, request, and scale the storage up to 520 gigabytes or 12 gigabytes for Premium v3. Also, you may know about the current problems with scaling in Azure App Service Environment v2. This is the previous version of dedicated environment. Scalability and changing the size of the IC will bring you to wait approximately 30 minutes, sometimes more, sometimes less. Just remember, ICV2, the old one, has no instant scaling capabilities. The issue were not observed on ICV3 and Premium v3. And here is the pricing. In conclusion, I would like to show you competitive table of the costs of these three options. Each of the service plan has a different instance size, both in terms of memory, number of virtual cores, and the price of instance. I already mentioned about ICv3 earlier that are different pricing models, but here I give a standard IC service plan deployment model. Regarding the old plan ICv2, the stamp fees was gone in v3, which was, by the way, more than $1,000 per instance per month. Added the ability to make a reservation for 1 or 3 years, which will help you to save up to 45% of your money. Of course, Premium v3 looks cheaper than IC, but you should remind that IC is chosen primarily for isolated the computing services and ability to serve large scale and high load. Let's talk about network traffic and its isolation. Usually, there are intended in isolation under the infrastructure design process and during preparation for compliance assessment. Here is a simple isolation option for the traffic. Inbound traffic from the internet access to your app service, and then this traffic is routed to the internal resources via VNet integration feature. This allows you to control your outbound traffic from the app service to internal resources via user-defined routes, network security groups. Previously, this integration did not exist, but nowadays we are lucky to have this integration even for a shared environment setup. I remember when I had tried to run the first time this integration under the preview, and I've got an issue with internal routing. There was a need to add some additional parameters for web application configuration to be able route outbound traffic via integrated VNet. And here is another thing. This integration is one way. So for inbound traffic, to be able to access your application, even you'll need to use another feature that we'll describe in a minute. And now you can see the difference between Azure App Service and Azure App Service environment. The last one is already integrated with your VNet, and you do not need to put integration as one of the required steps in your infrastructure design. And private endpoints is the second one feature that required you to route internal traffic. You can use private endpoints for your Azure web apps to allow clients located in your private network to securely access your apps over privately. Private endpoint use an IP from Azure VNet address spaces, and network traffic between client on your private network and web app traverse over the VNet and a private link on the Microsoft Backbone network, eliminating exposure of this traffic to the public internet. Using private endpoints for your web apps enable you to secure your web app by configuring the private endpoints, eliminating public exposure, securely connect to web app from on-premise network that connected to the VNet using VPN or Express Route private peering. Avoid any data exposure from your VNet. The connection between private endpoint and web app uses a secure private link. Private endpoint is only used for incoming flows of your web app. And you should know that next moment, like after you create the first private endpoint, um, all public traffic over the internet will be terminated. And you should put a private endpoints to all your VNets to be able to securely access your app. This is feature allows you to build robust and enterprise level infrastructure. Um, you may want to know how, and I'll try to explain right now. This is the last topic for today. I want to cover, and it's an enterprise deployment reference architecture from Microsoft. This reference architecture demonstrates a common enterprise workload using app service environment and best practice for security of this workload. The main component of this architecture is app service environment. NIC must be always deployed in its own subnet within the enterprise virtual network, allowing a tight control of the incoming and outgoing traffic. Within this subnet, app service applications are deployed in one or more app service plans, which is a collection of physical resources required to run the app. Depending on the complexity and resource requirements, an app service plan can be shared between multiple apps. Each app service app is hosted in own app service plan, allowing each to be scaled independently if necessary. All resources required by those hosted apps, such as storage and compute, as well as scaling needs, are fully managed by app service environment infrastructure. Um, the application uses Azure Cache for Redis for cache management. A premium tier of Azure Cache for Redis is used, which allow configure cache for the same virtual network as IC, but in its own subnet. This provides enhanced security and isolation to the cache. An internal IC is deployed in the enterprise virtual network hidden from the public internet. It's allowed the enterprises to log their backend services such as web APIs and functions at the network level. Any IC apps with an HTTP endpoint can be accessed only through the internal load balancer from within the virtual network. The app gateway is configured to forward requests to the web app through the internal load balancer, and the web app itself goes through the internal load balancer to access the APIs. The critical backend components, that is the API and function, are effectively inaccessible from the public internet. Web application firewall. WAF on the application gateway protects the web apps from malicious attacks such as SQL injections and WASP top 10. It also integrated with Azure Monitor to monitor attacks using real-time logs. Network security groups can be assigned with one or more subnets in the VNet. There are security rules that allow and deny traffic to flow between various Azure resources. This architecture associated as separate network security groups for each subnet. This allows fine-tuning the rules per subnet as per the service contained in this subnet. Azure Firewall and service endpoints complement each other. While service endpoints protect the resources by restricting incoming traffic to originate from your virtual network, Azure Firewall allows you to restrict the outbound traffic from your applications. It is recommended to let all outbound traffic to pass through the firewall subnet, including service endpoint traffic. This allows better monitoring of the outbound traffic. Since the IC is internal to the virtual network, a virtual machines is used as a jump box inside the VNet to deploy apps in the app service plans. The pipeline builds the application outside the VNet for enhanced security and seamless RDP SSH connection. Consider using the recent released Azure Bastion as a jump box. So this is all for today, and thank you for your attention. I hope this information will help you to better understand the nature of isolated infrastructure and build robust and secure solution for your customers. Thank you.